All right, so we should be recording. So I just want to let you know that you're being recorded. Any personal stuff, don't put it here in the recording. All right, so I'm showing my quadratic table of contents, and today, 9/22, 9/22, we're going to start our intro on the factored form. And this form is the one with which has two parentheses, two sets of parentheses. It should be equal to 0. Okay, and for your assignment, you're just gonna take notes today and then try the last problem on your own. And then you're gonna make up for anything that you haven't done the past days. Okay, you can make up on OneNote problems DAF, which was yesterday. It's also in your notes. This 4 are this 3 later. Okay. So that takes care of our table of contents today. Okay, now we go back to September 17th, wherein we talked about the different forms of quadratic function. And we're done with vertex form, wherein you can find the vertex. And if you multiply the square parts, this x minus h, that would remove the parentheses. And whatever answer we have, that's going to be the standard form. And we did that yesterday because the standard form doesn't have any parentheses. So now we're going to move to factored form, wherein you have two parentheses. The x plus p and x plus q, and p and q is any number. You still have an a there, which is like your slope. So this is where we're going to focus today in factored form. And there's a lot of vocabularies that they use just for this factored form. Okay, so we move on to our lesson today. And the vocabularies are zeros, roots, solutions, and intercepts. And they mean the same thing. Okay, roots of an expression are the variable values which cause it to be equal to 0. Okay, so roots are used when you're given an expression. Usually, because people switch these words. But roots are for an expression. Expression doesn't have an equal sign. If we have an equal sign, then we're dealing with equations. And we're going to be using the word solutions instead of roots because we're dealing with equations. Okay, and then the third word is zeros, which is the same thing as the two other words, but we use it for function. And then the last word is x-intercept, which is used when you're graphing, when you're given a graph. Okay, so 4 different words that mean the same thing, is just different usage. And they're always going to ask that during the test. They're going to solve for solution or find the zeros, find the x-intercept, solve for the roots. They're all meaning the same thing. Okay, so here's an example at the bottom of that. And we are using x minus 3 squared minus 4 equals 0. And this is in the vertex form because it's got one set of parentheses and then there's a number outside. So this is the vertex form. And if we graph it, we're going to start from the vertex, which is the number inside the parentheses is -3. We always change that into the opposite sign. So the vertex is at 3, -4. Okay, and the a of this is 1. So it follows the pattern of 1, 3, 5. So if this is the vertex, it's going to go 1 to the side and 1 up, 1 to the side and 3 up, 1 to the side and 5 up. Okay, and it's going to be the same thing on the other side because parabola are symmetric. Okay, so now that we came from the vertex, as we graph this, we are crossing the x-axis, and the x-axis has 2 points. This graph crossed the x-axis exactly at 2 points, and that's what we're going to be focusing today. Those 2 points are going to be inside the parentheses, and we're going to be solving for those. Okay, so if we're going to write down, we're going to type in the first answer to, we're just going to be talking about the x's. All right, so the first example, you have the equal 0. That means this is an equation, and we're going to use the word solutions. So for the first, because that's an equation, we're going to put solutions. And then just make it bigger so it stands up. Okay. And then the solutions of the graph is 1 and 5. Okay, and for the next one, we have f sub x. Therefore, we have a function. And for the function, we use zeros. So instead of solutions, I'm just going to put zeros. And the same, it's just the same thing. So it has the same number. It's still 1 and 5. Okay, all right, so next, we're just given x minus 3 squared minus 4, no equals, no f sub x. That means we just have an expression. So we're going to use the roots in place of the 0. Because now we're dealing with expressions. And still, the roots are 1 and 5 because we are talking about the same graph. All right, and the last one, it's still the same graph, but we're talking about the graph. So now we call it x-intercept. The fourth and final word that means the same thing. Okay, and this is going to be written differently because when we talk about graph, we always have pairs. So instead of just saying 1, you're going to state that as 1, 0, and 5 comma 0. Okay, so it means the same thing, just different words. All right, so make sure that you type it or you write it in your own notebook. Okay, so when we're talking about factored form, the hero here are the x-intercepts. Okay, so next would be the computation side. The zero product property means that if A times B, AB as A is a factor times B is another factor. If it's equal to 0, then A would be 0 or B would be 0, or both of them have to be 0. So we have 4 examples here, and all of them is equal to 0. Once you see that it's equal to 0, this zero product property is gonna come in. And I think a lot of you already have done this when you were in freshman, because you graph quadratic or parabola. But I'm just gonna show how you're gonna be solving for x given the factored form. Okay. So for the first one, f of x, 3x and x minus 5 equals 0. Okay, our goal is to find the x. Since this is an equation, our goal is to find the solution. When it says solve, you're looking for the solution. Okay, you're looking for the x-intercept. You're not looking for the y-intercept. It's just the x-intercept that you're trying to get. And x-intercept are the x's. So in the first example, we have 3x times x minus 5. You see only one parenthesis, but because you can also put a parenthesis inside of 3x. Okay, so that way you have two sets of factors. And then you just solve it. So 3x equals 0. And then to get rid of times 3, you're going to have to divide by 3. So x is equal to anything shared by 3 people, nothing shared by 3 people, those 3 people is not gonna get anything. And that's how we are solving for x. Okay, our goal is to find x. That's how we solve for x. Same way with the other factor, x minus 5 equals 0. We just need to get rid of the minus 5, and that's adding 5 to both sides. And we will get the value of x. So the 5 on the left side cancels, and it adds to 0. So our next x is equal to 5. Okay, so we do a little quick graph. This is our x-axis, 2, 4, 6. So the first x is at 0. And then our next x is in the middle of 4 and 6, which is x equals 5. And then whatever is in the middle, that's going to be your line of symmetry or angle of symmetry. And then we could just quickly graph this. That's what this factored form looks like when we graph it. So this is going to the first example. All right, so it's very simple. We're going to do the next one. It's x minus 4 and x plus 7. It's also equal to 0. So x minus 4 and x plus 7 equals 0. Okay, so we're going to do the same thing. Equate each factor to 0. X minus 4 equals 0. Add 4 to remove the 4. So x is equal to 4. That's the first one. And then the 7, the next one is x plus 7 is equal to 0. Get rid of the plus 7 by subtracting 7. So cross the 7 on the left side, and we're left with just x equals negative 7. Okay, and we found our two x's. We are able to solve our second example. Okay, and just graph it. So negative 2, negative 4, negative 6, negative 8. And we have the 1 on the 4, and then on the negative 7. So x is equal to 4, x equals negative 7. Okay, then find the middle. There's a half. 1, 2, 3, 4, 5. Half of it would be 2.5. Plus we have the small one. So the parabola is going to have its line of symmetry somewhere between negative 0 and negative 2. So that was fast. Okay, so the next one, I'm still going to show it, but if you already know how to do it, please go ahead and continue those example 3 and example 4. All right, example 3 has two numbers to remove. So this is not a quick one because you have 5 on the x. We write that down, make it equal to 0. Okay, and then get rid of the subtraction because we're trying to find x, so we're working backwards, the opposite of PEMDAS. So in PEMDAS, you do multiply first before subtracting, but because we're doing the opposite, we're going to be remove the subtraction first by adding on both sides. That would cross out. So we're left with 5x equals 0 plus 2 is 2. And then we can already get rid of the times 5, and times 5 is divided by 5. Okay, so 5 goes into 2, 2 is smaller than 5, then I can already write x is equal to 2/5. Okay, and x minus 5 is very easy because we only have to remove minus 5, and the opposite of adding minus 5 is adding 5. So our other x-intercept is positive 5. Okay, we have a fraction and then a whole number. So when we graph it, one, 2, 3, 4, and 5. Okay, so the 5 is going to be here because it's a whole number. Okay, and the fraction 2/5 is 40 cents. Okay, so it's less than $1. It should be here. From 0 to 1, all I need to do is to divide this 1 unit into 5 because we have a divided by 5 there. So 1, 2, 3, 4, 5. And then out of 5, we're going to take the 2. So that's where our 2/5 lie on that graph. Okay, so just draw your parabola. And 1, 2, 3, 4, and 2/5. So our line of symmetry is somewhere past 2. All right, question at this point.
And just so you guys know, the LOS, the line of symmetry, is the same as the AOS, the axis of symmetry. We use them interchangeably, but just in case you were like LOS, and if you weren't aware, that middle line is the same as the AOS, the axis of symmetry, just the X equals, and then whatever the X value was of that vertex point.
Okay, so that's another X, the AOS or the LOS, that's also another X, but that X should be different from,
right in the middle, right in the middle of the two X intercept values.
Mm-hmm. So it's our middle guy.
When something's symmetrical, it's the same on both sides. So that line goes right through the middle of the parabola. So if it was a piece of paper and you were to fold the paper on that dotted line, there would be the exact same amount of parabola on each side.
Yeah. So if we fold it, it should be kind of like this.
Yep.
And that's where the line of symmetry is. Okay. All right. So we're down to the last one, and the last one is just 3x minus 8. And you don't see any two sets here, but you just see the 0. So you know that you're going to call on the 0 product. But to rewrite this, we don't distribute the square. We write the two terms, the binomials, separately. Binomials because it's got two terms. And it's equal to 0. Okay, so if I solve for x, there's gonna be, because they're the same, then it's gonna have the same x-intercept. Okay, so we get rid of the subtract 8 first. Every time we have a number on the x, we have a coefficient. This always gives you a fraction. So this will cancel out the 8, bring down the 3x. The 8 now is added to 0 on the other side. So equals 8, and then divide by 3. So we have x equals 8 over 3. All right, can 3 go into 8? Yes, because 8 is bigger than 3, then it's going to go to 8. So we kind of make 8 tick marks, group them in 3, because it's easier to do tick marks if you have a small number. Okay, so we formed 2 groups. So big 2, and there's an extra of 2 because we weren't able to form a group of 3. So it's a remainder 2, and we always put the divisor at the bottom. Okay, so 8 over 3 is exactly the same as 2 and 2/3. And we can also graph it. Okay, so we have our 1, 2, and 3. We have 2 groups, so we put it past the 2. And then from 2 to 3, we're going to separate it into 3 equal parts. Earlier it was 5 because 5 is the denominator, but this time the denominator is 3, so we're going to have to do it into 3. And then, so the 2 is here, and the 2/3 would be taking the second. So this is our x equals 2 and 2/3. And then we have 2 of them, so it's the same space. Therefore, we're just gonna have a parabola that's sitting on the x-axis. So you have the x-intercept. You also have the vertex, all at the same space. Okay, but it's not gonna be the same as the parent function, y is equal to x squared. Everything, the vertex, the x-intercept, the y-intercept, and the vertex are all in one point for our parent. Okay, so the children sometimes work is going to have the same x-intercept and vertex, and sometimes they're going to have different points. But those are all possible to happen. So take a picture of your work and put it in your notebook. Okay, so if we're given a factored form, we can already graph them by just knowing where the axis lies. It's very important. Okay, so we have a taste of graphing, but on the next examples, besides the x-axis, we're also going to graph the vertex. And to graph the vertex, it's very easy because once you get the x, those two x, you look for the middle, and that's where the line of symmetry or the AOS is gonna look like. So we can do it in a graph, or we could just add those two x's and then divide it by 2, and we'll still get the h. Okay, so once we get the h, that's the middle x, we're gonna plug it into the equation so that we get the k. So if our equation is f sub x equals x minus 2, x minus 10, we're going to replace whatever we get for h into the x's and solve it to get the k. And that's what we're going to do with this example. And later on, you're going to have to do it with the second example. Okay, so yeah, we're given a factored form, 2 sets. And there's an fx, that means it's a function, so we're going to graph it. First, we're going to get the roots, or the zeros. F sub x, okay. So first, get the x-intercepts, and then we get the halfway, and we will be able to solve for vertex. Okay. All right. So first, we're going to start with the first factor, x minus 2 equals 0. And this is the only number that we're going to get rid of. So we know that x is equal to the opposite of minus 2, which is 2. And then on the next one, we have x minus 10, only one number to remove. So x is positive 10. And now we have those two x's. We can already graph them. 2 and 10. 10 is right here. Okay. So halfway would be counting how many spaces in between. And that counting it is 8. So half of 8 would be 4. 1, 2, 3, 4. So this would be our line of symmetry. Line of symmetry is very important. X equals 6. All right, to get that algebraically, we just add 2 plus 10, and that is our h. So the first intercept is 2 plus the next one is 10 divided by 2 would be 12 divided by 2, which is 6. So this is 6. Okay, so once we have the h, then we need to get the k. All right, so to get the k, we're going to use this equation. So this equation is f of x equals x minus 2 times x minus 10. Okay, I'm going to replace all the x with h. And this will give me the k. So k is y, or the combination of f of h. Okay, now I'm going to replace the h with 6. So this gives me 6 minus 2 is positive 4, and 6 minus 10 is negative 4. Different signs subtract, and 10 is bigger, so it gets the negative. Okay. And then just multiply these two. 4 times negative 4 is negative 16. And that's our f sub 6, or our k. Okay, so vertex being the h comma k is equal to 6 comma negative 16. Okay, and negative 16, if you make this by 2's, negative 2, negative 4, negative 6, negative 8, negative 10. And this is negative 20. 6 would be here. This is your K, and this is your H. So here is our vertex. The negative 16. One is to 1, 1 is to 3, and then 1 is to 5. 1, 2, 3, 4. Okay, I cannot do that because I'm doing by 2's. My y is by 2's. So it's not gonna give me a correct count. Okay. Okay, and last, you're gonna be doing it on your own. There's just some things that would help you because this one is written differently. So the last one, this is what you need to be doing, is you're given a factored form, but you're gonna rewrite it into vertex form. And you can do the vertex form if you know your vertex. So you can get your h over k by finding the x. All right. What's different with this given example is the first one, 1 minus x. Usually x comes first and it's positive. And then you have the number. So the number here, x comes second here, and it's a negative. So we know that if it's a negative x, it's gonna point downward. But to make the x go to the left side and make it the positive, you can always call for that negative. Okay, when we have the negative, when we're adding or subtracting polynomials, once you have a negative outside, all the signs inside changes sign. So the 1 becomes a negative 1 and the minus x becomes x. And you can do this as long as you don't remove the negative. Okay, Now, once our x is positive, then we can already switch them. X first, and then -1 after. And then don't forget that you have a negative. So now we have put the negative side on the a. Then we can already copy the x plus 6, which you're going to be doing. Okay. So your parabola should be pointing downwards. And then first one that you're going to do is to get your vertex, x-intercept. It's very easy. You have those two. And then once you have the x-intercept, you're going to find the h, then find k. Once you have the vertex, you're going to write it in vertex form. And vertex form is y equals, you get an a outside, x minus h squared plus k. Okay, so once you have the h and the k, then you can make your vertex form. See the negative here, it should be a negative for a. All right, so yeah, do this. And 150, we get out 225. So you get 35 minutes. Do this, and then if you didn't finish yesterday's, also do that DEF. Here is an example. And yeah, I'm gonna stop recording at this time.